Good afternoon. My name is Zsófia Vincze, and I would like to present you my PhD topic, which is the evaluation and comparison of different complete denture processing technologies. I'm a dentist from the Department of Preclinical Dentistry. My supervisor is Kristina Márton. My scientific methodology supervisor is Bianca Goazio. My vision is to resocialize edentulous patients into the community by providing them a durable and well-functioning complete denture. I have two specific goals. The first is investigating the mechanical properties of denture-based resins, which is a systematic review and network meta-analysis. Edentulism is very common, especially among older people, which leads to functional limitation and can cause social isolation. According to the United Nations, by the end of 2050, there will be twice or even 3 times more aged person than nowadays. That is why we have to be prepared and be able to provide a solution for them. The most common treatment option is the complete denture, which is conventionally made by the dental technician, but it can take longer time. Using the newer CAD/CAM technology, the additive 3D printing or subtractive milling, we can reduce the cost and number of processing steps needed. When a patient is using a complete denture, it repeatedly undergoes flexing during mastication, and it can cause a fracture or a crack. And if the surface of the denture is rough, more bacteria and candida can connect to the surface, and it can lead to oral infections. So that is why our aim is to investigate the mechanical properties of different types of denture-based manufacturing techniques. Our clinical question: is there a difference in mechanical properties of CAD/CAM produced complete dentures and conventional complete dentures? Our main outcomes were flexural strength, surface roughness, and the elastic modulus, and we were able to investigate also the Vickers hardness and the impact strength as well. Our hypothesis was that there is no difference between the conventional milled and 3D printed denture bases in terms of these outcomes. With this study, we would like to find alternative methods to produce complete dentures quicker and cheaper without the decrease in quality. With this search key, what you can see, we conducted this systematic search at the end of November 2023 in 4 main databases. And in the beginning, we had a little bit more than 17,000 articles, but by the end of the selection process, we could include 63 eligible full text. Because of the shortness of the time, I would like to show you only 2 of our results. First is the flexural strength, which is the ability of the material to resist bending forces, bending deflection, when force is applied to the surface. High flexural strength is very, very important when we are talking about complete dentures, because as I mentioned before, it repeatedly undergoes flexing during mastication, and an average bite force of a human can be around 100 Newton, but the maximal can be even more, around 300 Newtons. So just to put it simple, if the flexural strength is low, our denture can be broken. So that is why there is also an ISO standard for it, which says that the minimum flexural strength for an acrylic denture base has to be at least 65 megapascal. We can measure this by using the 3-point bending test when a specimen is laying on 2 support pins and the force comes from the top, and first it will bend the specimen and after a certain point it will break. Here you can see our plots. The first is the network plot, where the orange circle represents the 4 fabrication methods. The size of the circle represents the number of specimens which was investigated. The line between the circles show the direct comparisons, and the number on the lines show the number of studies where these comparisons were made. Altogether, for this outcome, we could include 37 in vitro studies. On the right, you can see our P-score ranking. Here the values range from 0 to 1. If the number is higher, closer to 1, it means that the likelihood is higher that the given technique is in the top rank. If it's closer to 0, it's more likely that the fabrication method is in the bottom rank. And our third plot is the heat plot. The heat plot contains point estimates of relative effectiveness for all possible pairs of fabrication methods, along with 95% of confidence interval obtained with random effect model. On the first row, you can see that the the effect was mean difference, and we can see that the difference between the milled and compression molded group was 14.76 in megapascal, and it was a statistically significant difference. That's why there's a star next to it. And the other results which I would like to show you is the Vickers microhardness, which is defined as the resistance to indentation. Dentures can be damaged by many ways. For example, during brushing, we can create scratches on the surface, and with that, we can increase the plaque retention and pigmentation, which can reduce the lifetime of our denture. So again, to put it simple, if the hardness is low, it can reduce the denture's lifetime. We can measure it by the Vickers hardness test when a pyramidal indenter is pressed to the specimen's surface with a certain load, and after that we can measure the size of the indentation, and using these numbers we can calculate the Vickers hardness number. For this outcome, we could include 16 in vitro studies. In this case, the injection molded group got the highest p-scores, so that's in the first place, but it was followed by, the milled technique. And which was interesting in this heat plot, that all the comparisons were statistically significant. The strength of our study is that we could include a high number of high-quality studies which used standardized measuring technique, but not all of the studies investigated all of our outcomes, and sometimes they used different measuring units. Also, the heterogeneity was quite high. In conclusion, we can say that milled denture bases showed superior mechanical properties compared to other methods, therefore they should be used in practice. But further research is needed to enhance the mechanical properties of material used in 3D printing. We could publish this study in the Dental Materials journal. My second project is the evaluation of microbial adhesion of traditional PMMA resins and CAD/CAM-based dentures, which will also be a systematic review and network meta-analysis. As I mentioned in connection with my first project, edentulous is very common, especially among older people, and the most common treatment option is the complete denture, which is either done by using the conventional techniques or the newer CAD/CAM technology. Even in a healthy person's mouth, there are bacteria and candida living, but in case of a denture wearer, it can connect to the denture's surface and can cause denture stomatitis, which can reduce the patient's quality of life because they can feel pain during eating, swallowing, or speaking. And it is especially dangerous in case of immunodeficiency or immunosuppression, because the bacteria can spread to other organs and can cause an inflammation there. So that is why our aim is to investigate the microbial adhesion of CAD/CAM-produced complete dentures and conventional PMMA dentures. Our clinical question: is there a difference in prevalence of microbial adhesion of CAD/CAM-produced complete dentures and conventional PMMA ones? Our hypothesis is that there is no difference between the conventional and CAD/CAM denture bases in terms of microbial adhesion. With this study, we would like to reduce the incidence of denture stomatitis. Here you can see our search key. With this, I conducted the systematic search in 4 main databases at the end of October last year. And we collected a little bit more than 5,000 articles. And right now we are working with 32 eligible full text. I'm in the data extraction phase. Also, we still have to do the citation chase. Hopefully, we will be able to add 1 or 2 more articles to the project. So just to sum it up, I was working on these 2 projects. The first one was published in January, and I plan to submit my second study this September. As additional activities, I would like to mention that I'm involved with the teaching at the Department of Preclinical Dentistry. Also, I participated on some conferences with a poster presentation, and I have 2 publications. And I would like to finish my presentation with the words of Edward Teller: "The science of today is the technology of tomorrow." Thank you.
Do you plan to make subgroups
in case of the second topic. Yes, in my second topic there are many things which are different in the different articles. Right now we plan to create two main subgroups based on incubation times, one which will be 90 minutes of incubation and one which is 48 hours of incubation. But when we finish the data extraction, of course, we have to sit down together with my team and maybe we will be able to create even more subgroups if we have enough data, hopefully.
As we know, for milling, the block was already done, and for the 3D printing, we just added the layers. So my question is, do you see anything about the influence of these types of manufacturings on if they can influence the results?
Yes, thank you for your question. I'm sure it influences our results. We investigated several mechanical properties, and I believe that since the milled block is made in an industrial environment, that's why it's stronger. Let's say that's why the milled group always was better than the 3D printing. Adding the layers after, so like building it layer by layer in our tiny laboratory, maybe that's why it's not so good in terms of mechanical properties yet.
And is there any evidence, or is just a guess?
I'm sure that they investigated this topic because it's a very hot topic, but I didn't read any articles so deep in the physical and chemical approach, but I will. Thank you.
Thank you.
I would like to ask you that we know that there are different kinds of 3D printing technologies. And can you divide them in subgroups in the first project, or can you just pull them together, or what was your...
Yes, we had a lot of discussion about it. Thank you for the question. At the end, we pulled them like everything together because we didn't have so many different articles. Most of the studies which we included used the SLA or DLP printers, and also the layer thickness was not always the same. Most of the time it was 50 microns, but sometimes 100 or 25, and also the building angle was not the same. So again, it would be nice if we would be able to create many subgroups according to these, but then we wouldn't have enough studies to include them in like one group. So that's why we just merged them together.
My question is also regarding your first project. You mentioned subgroups, but your heterogeneity was still very high. What could be the reason behind?
Yes, it was sadly quite high. I think it was because these studies used different materials, different brands, and of course that's a huge impact on the heterogeneity, and also sometimes the manufacturing protocols were also not the same because the manufacturer's guideline was not always 100% the same. So I think that was the main reason for it.
I have some practical questions. Basically, your research is about 3D printed base trays.
Sorry?
Your research is regarding 3D printed base trays. And my question is, how do we fix the tooth in this base tray? So we print it alongside with the base tray, or we lute them together, or what are the possibilities?
Yes, thank you for the question. So if we are talking about printing, then because of aesthetic, we will need different material because the base plate is like pinkish, but of course the teeth has to be white. So we have to print them separately, and after that we have to lute them into the base. That's another very interesting question, how strong this luting can be. Of course we did not include this for these studies, but I read some articles which were focusing on that, so maybe in the future I will also have the possibility to investigate this. And if we are talking about milling, we can either do the same thing, just mill them separately, the base and the teeth, or we can just use monoblocks, which are like, so they have the whitish part and the pinkish part as well, and we can achieve very aesthetic results with that.
Do you know the difference between the conventional, the milled, and the 3D in terms of the degree of conversion that during polymerization, how polymerized they become?
Thank you for the question. These studies, which we included, did not mention it, but I know that there are differences. I think that the 3D printed was a little bit lower, the polymerization rate, and the milled was a little bit higher, but I don't quite remember the traditional one, sadly. I have to read it again.
And do you have information on how much filler particles they have, or do they have, or are these around the same amount? Because that would be important to compare technology to have at least the composition to be around the same.
Yes, thank you for the question. Usually when there's a study, they mention what kind of chemicals the material has. They don't always have the exact percentages because it's like industrial secret, but of course there is like at least a range, which right now I cannot tell you exactly. But of course it also influences the results, and it's a very important question when we are talking about these.
So my question's with the first study, the mechanical properties of different fabricated dentures. So you found some differences. Are they clinically relevant? And can you consider in answering this question the remarkably lower bite forces that edentulous patients can produce just because of the movement of the dentures and things like that? So I'd just be really interested, you know, from your clinical perspective, that you've got some very interesting results, but do they actually have any clinical relevancy? Can we use all of the different types of dentures, you know, with respect to someone who is edentulous?
Yes, thank you very much for the question. Yes, so all the fabrication methods and the dentures produced by these techniques reached this minimum criteria which I mentioned, which was the ISO standard. So if we just see only this, we are able to use all the techniques. But if we really want to give a patient a very long-lasting denture, I believe we can consider if we are choosing a milled instead of a 3D printed, because, for example, maybe they accidentally drop it, and maybe a milled one will not break while a 3D printed will. Of course, it's not very often, but I think there can be some differences when they are using it.
Thank you. And I guess with any of the CAD/CAM design, they can always just ring up and ask someone to just press print and create the second replacement. Yeah. And I just think because access to care for this group of patients is very, very important. And so have you got some comments on the CAD/CAM, the different procedures about are the 3D printed ones cheaper, more accessible versus the milled prostheses? just so that we can actually address the needs of this important population?
Yes, so when we first start to work with digital dentistry and we have to buy these instruments and gadgets, of course it's very, very expensive. But if there's a bigger clinic or a bigger laboratory who already uses these, so they don't have to buy the machines, because they use it for other things as well, and we consider only the materials, then it can be cheaper than, for example, the conventional ones. And if I want to compare the milled and the 3D printed materials, 3D printing is cheaper for sure. So we really have to check the individual case. If the person cannot afford the more expensive one, but because of 3D printing is cheaper and we can produce it very quickly, then maybe that's why we will choose that for our patients. So we really have to take everything into consideration when deciding.
Regarding your second topic, I just noticed that in your search key, in the second or third part of the search key, you've basically filtered for the cocci. So Streptococcus, Staphylococcus, are they relevant in the oral cavity that you felt it necessary to?
Yes, I added it to the search key because, of course, Candida albicans is the most researched and the most important. But I was curious if there are available studies which study not just Candida but any bacteria, and if I'm able to compare them as well. Right now I'm in the data extraction phase, so I read most of the articles. Sadly, I think we will not be able to add them to the network the meta-analysis part, but that's why I added to the search key, because I was curious if there are any new studies which investigate this as well.
Thank you. Another question of mine is regarding your first topic. Can you elaborate a bit between what's the difference between the lower and the upper part of the leak heat plots? So
Yes, so in the lower part, we check the whole network, so not just the direct comparisons are there. That is why there is a blank space in the first row and in the last, because there were no direct comparison between the injection molded and the 3D printed group. So without the network, we wouldn't be able to tell the differences between them, but in the lower part, when we see the whole network, we could calculate the mean difference between those groups as well.
And my last question is related to the p-scores, because we're dealing with a frequentist network matter here. So is the magnitude, or I don't know, the largeness of the p-score has any meaning, because milled has 2 times as high p-score than compression molded? Does this mean that that's 2 times better?
I wouldn't say it means it's 2 times better. I would say it's more likely that it will be better if we would create a new study. So the probability is higher that it is better.
It's just a comment after the professor comment. I just remember one point. Sometimes we need to be cautious with the digital materials, and when we have a 3D printing device as a, I don't know, occlusal splint or a denture as you have, we just need to think it's breaking because the power is transferred, the stress is being transferred for the device. So it means it's not being transferred for the bone, so you have the fracture in the device. Yes, And for example, if we just consider the milled material, sometimes it's resistant. It means the stress will be transferred for the bone. So maybe you don't have a broken device, but maybe you have a fracture in the bone. So it's a thing to think about and to discuss. And I know it's in the very beginning, in the research, I mean, because there are some points that are not touchable yet. But I think it's for the future.
Do you have any data regarding toxicity? Because when we use 3D printed materials, it's often a question if we have residual monomers that could occur and cause toxicity and irritation in the oral mucosa.
Yes, thank you for the question. That is true. It's very, very important, and also a lot of researchers investigate this topic, and we couldn't include it to this project. But these materials and the technology is improved in the past years, so the monomers are not that high, so it is safe to use in the oral cavity now, yes.
Milling material and printed material, are there any weight difference? Because in full denture, weight is also considered to be advantage or disadvantage, depending on which jaw we are talking about.
Thank you very much. I think the difference in weight is not so big, so I wouldn't think that because of the weight the upper will just fall or something like that. So the difference, I think, is not much.
I was thinking about the stabilization of the lower one more than the falling of the upper, but yes, you are right. So if there is no clinical relevance, weight is not really a consideration. Okay. No. Thank you.